Hello, I was assigned chapter 22, problem number 14. Chapter 22 focuses on electromagnetic induction, and the problem 14 is in section 22.3, which focuses on magnetic flux. So, the problem reads, a loop of wire has the shape shown in the drawing, and here's the drawing right here. The top part of the wire is bent into a semicircle of radius equal to 0.20 meters. The normal to the plane of the loop is parallel to a constant magnetic field, which is equal to 0 degrees of a magnitude of 0.7 Tesla. So they're asking, what is the change in the magnetic flux that passes through the loop when starting with the position shown in the drawing? The semicircle is rotated through half a revolution. Okay, so this problem is from section 3, and we are given the radius, which is equal to 0.20 meters, and we also know that the normal to the plane of the loop is parallel to a constant magnetic field. We also know that the constant magnetic field is equal to 0 degrees. And then we're also given that the magnitude is 0.75 Tesla. So they want us to find the change in the magnetic flux that passes through the loop through a half revolution. So we can assume that as the handle turns, the loop changes. So we can think of the loop as being divided into a rectangular portion and a semicircle portion. So initially, the initial area of the loop is equal to the rectangular area plus the area of the semicircle. And that's what I have right here. So this is my formula section. If you go look in the textbook, magnetic flux is equal to BA cosine constant of magnitude. So the magnetic flux that passes through a surface is given by equation 22.2, where B is the magnitude of the magnetic field, A is the area of the surface, and this symbol here is the angle between the field and the normal to the surface. So the magnetic flux is proportional to the number of magnetic field lines that pass through the surface. So we can just use this formula, and we have everything. All we have to do is find the area. So the final area is equal to A rectangular minus 1 over 2 pi r squared. So this is going to become important later. And after the loop is made, the change in magnetic flux is the constant magnetic field minus the initial. So finest minus initial. So that's BA cosine angle minus BA initial cosine angle. So if you manipulate the formula here, this is the result. We have B cosine A minus A initial. So we just manipulate it that way to make it a little easier. And now we can substitute our A's. This is where the earlier formula becomes important. So we substitute those into here, and that results in this more simple formula, negative pi r squared B cosine angle. So we can just plug in everything. So we have negative pi times 0.20 meters squared. Don't forget to square the radius, and a 0.75 Tesla, and then cosine 0. So we do 1 over 2 pi r squared because the area of a circle is pi r squared, of course, and that is half since it's a semicircle. So once you plug and chug, you get your final answer, and it is a negative 0.094 Weber. Thank you.